Good morning, children. Welcome back to Ican Physics Academy. Now, in this class, we are going to see CBSE previous year question 2021 55 bar 4 bar 1, section D. Okay, let's enjoy the class. Question number 31A. First question. Define a mobility of electron. Give its SI unit. Mobility. So, the mobility is denoted by mu. Mu equal to Vd by E. So, mobility is defined as drift velocity acquired per unit electric field, where mu is the mobility, Vd is the drift velocity, E is the electric field. Okay. Now, what is the unit of drift velocity? Meter per second. What is the unit of electric field? Volt per meter. Now it becomes a reciprocal. So when it becomes reciprocal, meter per second into meter per volt. So meter becomes meter square. So meter square. So power plus 1 goes to the numerator as minus 1. So minus 1. So plus second goes to the numerator as minus. So meter square per volt per second is the unit of mobility. So what is the equivalent unit of meter square per volt per second? The same method we can derive. Okay. For drift velocity, meter per second. For electric field, Newton per coulomb. Now it becomes a reciprocal. So meter per second into coulomb per Newton. So meter coulomb. The power plus 1 goes to the numerator as minus 1. Minus 1. So power plus 1 goes to the numerator as minus 1. Okay. So meter per second coulomb per Newton is the equivalent unit of meter square per volt per second. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. Now the question number 31-2. A steady current flows through a wire AB as shown in figure. What happens to the electric field and drift velocity along the wire? Justify your answer. Now, let us consider a conductor AB when it is connected with the external source. Okay. So now the current is flowing from positive terminal to negative terminal. So when the current flows through here, so that we are establishing the electric field in this direction, that is A to B. Then automatically the electrons are drifted towards the positive terminal. Okay. So electrons are drifted. So what is the relation between the electric field and the drift velocity? This is the question. Okay. So what is drift velocity? The velocity with which the free electrons are drifted towards the positive terminal when the electric field is applied. Okay. Then what is the formula for drift velocity? Vd equal to A tau. Okay. So where Vd is the drift velocity, A is the acceleration, tau is the average time for successive collision, or otherwise it's taken as relaxation time. Now what is the unit of drift velocity? Meter per second. Okay. Now it experiences a force. We know that F equal to ma. Okay. So electric field is defined as force experienced by the unit charge. But in our question, what is the word given? Electrons. So for instead of Q, we can write E equal to F by E. So the division E comes with this as multiplication. So E equal to F. Now compare these two. Okay, F. Okay. So automatically these two sides are equal. So Ma equal to EE. So A equal to EE by M. Now substitute the value of A in this equation. So drift velocity equal to A. So what is A? EE by M. E by M into tau. E by M into tau. Okay. Now, E is 1.6 into 10 to the power minus 19 coulomb. Tau is the average time for successive collision. That's also constant. M, mass of electron, that also constant, 9.1 into 10 to the power minus 31 kilogram. So how we can relate these two? That is, when the drift velocity is directly proportional to electric field. So from that, what we can justify our answer? When the electric field increases, the drift velocity is also increases. On the other hand, when the electric field decreases, the drift velocity is also decreases. Okay, do you get it now? Do you have any doubts? No doubts. Okay, the next one, 31, third. Consider the circuit shown in the figure. Find the effective resistance of the circuit and the current drawn from the battery. Okay, right. Now, look at the diagram. Now, you can give the name to the resistances R1, R2, R3, R4 and R5. Now, look at R1 and R2. These two are connected in series. Okay. So, Rs equal to R1 plus R2. That is equal to 14 plus 10 equal to 24 ohm. Now, look at these two. This is also connected in series. Okay. So, Rs equal to R3 plus R4. That is 10 plus 10 equal to 20 ohm. So, now we have two series resistances. So, R1, then it becomes R2. Okay. Now, we can modify this circuit diagram. Okay. So, how we can modify? Okay. So, this is R5. Okay. Now, what is the value of R5? Is 30 ohm. Now, R3 and R4 become RS2. Now, it is RS2. Okay. RS2. And its value is 20. So, 20. Now, these two becomes RS1. So, that RS1 and it becomes 24 ohm. Okay. Now look at these three resistances. Now they are connected in parallel. Okay. So when it is connected in parallel, 1 by Rp equal to 1 by R5. R5 plus 1 by RS2 plus 1 by RS1. Okay. 1 by RS5 is 30 plus RS2 20 plus RS1 is 24. Okay, so when you are taking the common LCM, so the common LCM becomes 120. Okay, so 120 by 3, 0, 0, 1, 3 is 3, 4, 4 times of this one. Okay, now 0, 0 getting cancelled. So 12 by 2, 6. 6 times of numerator. Okay. So 120 divided by 24, then it is 5 times. So 5 times of numerator. So 4 plus 6, 10. 10 plus 5, 15. So 15 by 120 is 1 by Rp. Okay. So Rp is in the denominator. So reciprocal the value. So when you reciprocal the value, Rp equal to 120 by 15. So 3 5s are 50. 2 5s are 10. Remainder 2. 20. 4 5s are 20. Okay. So 1 3 is 3. 8 3s are 24. So Rp equal to 8 ohm. Now these three resistances become 1, that is 8 ohm. So the circuit diagram becomes like this. It's 8 ohm and it is Rp. It's V. So what is the value of V? 6 volt. Okay. So what is the question? What is the current flowing through it? So B R, what we have to calculate? I. So V I R. So we are IR. So V equal to I R. How we can modify the formula? For instead of R, we can write RP. So what is B? B is 6. I only we are going to calculate. R. So what is the value of R? 8. So the multiplication 8 comes to this as division. So 6 by 8 equal to I. So 3 2s are 6. 4 2s are 8. So I equal to 3 by 4. This much of ampere. Okay. Do you get it now? Do you have any doubts? No doubts. So now the 31 R question la B la first question. Define electrical conductivity of a wire. Give its SI unit. Okay. So the next question is conductivity. Okay. So conductivity is denoted by sigma. So conductivity is defined as the reciprocal of resistivity, or otherwise the ability to carry the current. Okay. The unit of resistivity is ohm meter. So when it becomes reciprocal, OHM becomes MHO. The power plus 1 goes to the numerator as minus 1. So mho per meter is the unit of conductivity. Okay. Question number 31 B, second question. High current is to be drawn safely from a low voltage battery and a high voltage battery. What can you say about the internal resistance of the two batteries? So, question number 2. For low voltage battery, the internal resistance R is low. For high voltage battery, the internal resistance is high. The resistance is high. Okay. Okay. So question number 31 B, third question. Calculate the total energy supplied by the batteries to the circuit shown in the figure in 1 minute. Okay. Right. So for this circuit, we are going to use voltage law, Kirchhoff's voltage law. So what is Kirchhoff's voltage law? The algebraic sum of product of current and resistance in each part of any closed circuit is equal to algebraic sum of EMF in that closed circuit. Okay. So for that I want to take A, B, C, D. Now I is the current, comes A and is just a turn, so the same current I is flowing. Now the current comes to B, the same current is just a turn and flows through 6 ohm. When the current when the current I comes to C, just a turn. Okay. So product of current and resistance in each arm. Here current is I and the resistance is 1. Okay. So 1 I plus, here we can take 2I, plus, here we can take 6I, plus, here we can take 3I, equal to algebraic sum of EMF in that closed circuit. Just see the positive terminal. The positive terminal connected with the positive terminal. So that we have to subtract the EMF. Okay, how we can subtract? Greater minus smaller. So 10 minus 4. Okay. So 1 plus 2, 3. 3 plus 3, 6. 6 plus 6, 12. So 12I equal to. So 10 minus 4 is 6. So I equal to 6 by 12. So 1666. 2 6 are 12. So I equal to 0.5 ampere. Okay. So what is the question asked? What is the heat produced in 1 minute? So H equal to I squared R into T. Okay. So I squared. So what is the value of I? 1 by 2 or otherwise it's taken as 0.5. So I want to take 1 by 2. I square, so that it can be taken by 1 by 2 into 1 by 2. R. So what is the value of R? Is 12. Into time. So time is given as 1 minute. In 1 minute, how many seconds? 60 seconds. So 60. So 1, 2 is 2. 6 2s are 12. 1, 2 is 2. 3 2s are 6. 6 3s are 18. So 0. So this much of Joule. Okay. Do you get it now? Do you have any doubts? No doubts.